The danger that we face could not be more real.
The Washington Post reported recently that 33% of Americans rank global warming as the world's chief environmental concern.
What we found is that the climate is not changing as remarkably or dramatically or dangerously as people have been promoting.
Global warming simply says more oscillations. So we have fluctuations, but on average, temperatures are going to rise.
Disgraceful denial.
It's problematic because for the last 11 years, temperatures had been dropping.
Backpedaling and delay.
A lot of people are changing their minds.
Has brought us perilously close to a climate change catastrophe. And today we've moved beyond the worst case scenarios that were predicted by all the modeling.
Much of the East Coast is shut down today as residents prepare for Hurricane Sandy.
You've seen these horrific scenarios everywhere based purely on catastrophic hypotheticals that dramatically exaggerate even what the UN said.
We're moving past the debate about whether this is a problem into a debate about what we're going to do about it.
There has been a pervading climate silence. We're doing our best
These things are dictated by solar activity in the moon. They're nothing to do with mankind, and those who say that are just trying to make money out of it.
But as climate experts see glaciers melting faster now, there's suddenly a race against time.
President Obama promised to begin to slow the rise of the oceans.
We will respond to the threat of climate change, knowing that the failure to do so would betray our children and future generations.
My promise is to help you and your family.
But you can see it across the planet with your own eyes.
Alaska's glaciers and Arctic ice are pumped and studied and sampled for global warming.
The biggest single cause of global warming is the burning of fossil fuels. Oil is a problem, and coal is the most
It's about the
serious
theory
problem.
of man-made global warming on the heels of a major scientific scandal concerning researchers and their behavior.
The problem is this thin layer of atmosphere is being thickened
What we
by
found is that
all
the climate
of
is
the
not
global warming
changing.
pollution.
Americans rank global warming as the world's chief environmental
to a climate change
And as climate
catastrophe.
experts see glaciers
Global
melting
warming pollution that's being put up.
These things are
There has been a
dictated by
pervading
solar activity in
climate
the moon.
silence.
There's suddenly
We're doing
a
our
race
best
against
single
to
cause of
bring
global
carbon
warming.
into the atmosphere.
Because for the last 11 years, temperatures had
Profoundly,
been dropping.
we need to do better.
Climate change, global warming, carbon dioxide. As students at the University of South Carolina, we have heard these phrases a lot, in class, at events, and in the media. They have shaped a global debate and forever changed how we think about our environment. However, it's easy for some to think that such a large issue is beyond us, that our actions don't affect climate change, and that we can't stop it. Some of us even think that it's a hoax or a conspiracy, or simply not understood well enough to deserve our attention. But climate change is closer than we think, and even just our university in Columbia, South Carolina, makes a difference. Let's start with Earth. Earth has been warming for about 18,000 years, since the Pleistocene Ice Age. This is normal. Every 100,000 years or so, for the last several million years anyway, Earth enters an interglacial warming period that lasts for about 15 to 20,000 years, during which the Earth's temperature warms. What's not normal is that in the late 1700s, the Industrial Revolution changed many agrarian societies in Europe and America to industrialized urban areas. Factories were built, steam engines were used, and coal replaced other fuels. These activities emitted greenhouse gases such as methane, nitrous oxide, and the notorious carbon dioxide. The atmosphere trapped these gases, which caused the Earth to warm up like a greenhouse. Average land temperatures increased about 1 degree Celsius or 1.8 degrees Fahrenheit in the last 50 years alone. Wallace Broecker, a geochemist, was the first to call this global warming.
The instrumental record on this is very clear. We trust thermometers. Thermometers work, they're very straightforward. We can do a very good job of averaging the temperature among many different thermometers. And I think there's essentially no debate that the global temperatures have been rising.
So the liquid and glass thermometer is about 400 years old, and so keeping that standard as a control through time is really important.
There's an overwhelming consensus among the scientific community that this is due to the rise in greenhouse gases from human activities.
98% of climate scientists say that they believe global warming is real and that it is due to anthropogenic carbon dioxide inputs. This also has been very well scientifically demonstrated. I think it's pretty unambiguously true.
Observed data matches models that include both natural and human impacts. Natural cycles alone do not account for observed temperature increases. Land temperatures are predicted to continue to warm by 5 to 9 degrees Fahrenheit by 2100. Heat waves will be longer and more prevalent. There will be more warm days, and they will be warmer than we are currently experiencing. The term climate change refers to this warming and all of the other effects that greenhouse gases will cause.
Essentially, more carbon dioxide in the atmosphere will lead to a warmer climate and changes in the weather patterns that, different regions are used to. That means more violent storms, on average, warmer temperatures, less ice volume.
There has already been less snow cover and higher sea levels, and that doesn't even begin to scratch the surface of all the global changes that are predicted to occur. Precipitation levels will change dramatically, up to 20% in many places. Droughts and floods will be more extreme, which could greatly impact crop yields.
Countries that really have to worry about flooding and malaria, that's really bad. But there's going to be other regions where, guess what? They're not going to get as much rain. They're not going to have as much standing water. Malaria actually will probably decrease in those areas.
As the Earth heats up, the oceans will absorb a lot of the heat. This will cause a lot of changes, which many scientists are researching.
All oceanography is sort of basically about climate change in one way or another.
Many species, like corals, will face serious threats because they require a certain narrow temperature range to survive and thrive. Arctic ice will melt. This has already become a major problem. 2012 saw the lowest Arctic ice volume ever recorded, and 2013 is likely to see even less ice. Of course, there's a problem we all think about.
Polar bears are toast.
But this will also affect coastal areas worldwide. Adding this water to the ocean will cause sea level rise. Thermal expansion will also play a part in sea level rise. As the ocean warms, water molecules will move faster and further away from each other, causing the ocean's volume to increase. The ocean will change in many other ways because it acts like a carbon sponge.
As carbon dioxide is put into the atmosphere, the ocean takes up about 50% of all of the human emissions that are put into the atmosphere. And now this is great for temperatures because temperatures would be much warmer were it not for the oceans and carbonate deposition.
But this isn't a fix by any means.
As the ocean warms, it's going to become more difficult for the ocean to hold on to the CO2 that it has, and it's going to become more difficult for CO2 to be taken up by the oceans.
Carbon dioxide also makes the ocean more acidic.
Ocean acidification is sort of a difficult concept to grasp in terms of its threat. Right? You go to the ocean, your skin is not going to dissolve off your bones, but it is a problem because a lot of the marine calcifiers that require a certain level of acidity so their skeletons don't dissolve are at the base of the food chain. An example of this are the pteropods that live in the Southern Ocean. They're lentil-sized plankton at the base of the food chain. Now, if those guys start having trouble calcifying, the Southern Ocean food web will collapse. Baleen whales, penguins, all of the things that Pixar really relies on to make their movies.
Don't worry, whales don't eat clownfish, they eat krill.
Swim away! Oh look, krill! Even if we did see carbon dioxide uptake by the oceans as a fix, the ocean won't hold on to that carbon forever.
On longer time scales, what's going to happen is that due to large-scale ocean circulation and ocean mixing, all that carbon dioxide, which was sequestered in the deep waters, will move along the deep sea conveyor belt. Eventually it will upwell somewhere in the surface ocean, and now all of that carbon will be re-released into the atmosphere.
But global climate change won't be bad for everyone.
Longer growing seasons. Okay, shorter trade routes. We can go straight through the Arctic. You melt all that ice, straight shot. You know, we're really going to change our shipping lanes in a different way.
The most important thing to note is that there is uncertainty inherent in all of these predictions, which is why scientists talk in ranges. Some of this is because we don't know how humans will act.
When it involves humans, there's always a component that you can't model really well.
The Intergovernmental Panel on Climate Change, or IPCC, has attempted to model future climate change in different scenarios. If we had stopped emitting carbon dioxide in 2000, or if carbon dioxide levels climbed to 600, 850, or 1,250 parts per million by 2100. Scientists also don't know exactly how things like feedbacks will impact changes. This adds more uncertainty.
So a positive feedback would be something where as the Earth gets warmer, something happens which causes the Earth to get warmer still. So a great example of this would be melting of the polar ice caps. Whereas the Earth gets warmer, you have shrinking of the polar ice caps. Now those polar ice caps, when they're white, they're reflecting a lot of heat away from the surface of the Earth. As they shrink down, you absorb more heat into the ocean, and so it's a positive feedback. The warmer the Earth gets, the more propensity you have towards further warming. There are other climate feedbacks that are negative feedbacks as well. An example of that might be cloud formation over the ocean. A lot of biogeochemical models suggest that as the Earth gets warmer, you'll have more evaporation of water up into the atmosphere and more cloud formation. So just the exact opposite of the icebergs, those clouds are going to reflect more heat away from the Earth. So that might be a negative feedback that helps to regulate and mitigate the increases in global temperature.
It's hard to make decisions with so much uncertainty.
There's enormous amount of uncertainty associated with some of those projections. And the question is, how do you wrestle with that uncertainty? Is there a way that you can use information which is inherently uncertain in order to make still reasonable kinds of decisions? And that's a really difficult thing.
And even if scientists were certain, there's still the problem of communicating to the public.
I think there's a lot of disinformation out there about how our climate system works and how climate change influences our Earth. I think that there's a lot of fear.
I don't think that scientists are good at communicating to the general public, but I think part of that has to do with the fact that we have no incentive to do that. We are tasked with doing service research and teaching, and nowhere in our grants that we get are we told that we need to disseminate this information to the public. I really like doing that because I feel valuable, but it takes a lot of time, and I don't get credit for it.
I think that scientists, at the end of the day, we just suck at communicating the research that we do. We don't like to talk in absolutes. We like to talk in percentages. We like to talk in probability. And most people don't quite get it.
At the same time, scientists are the best hope we have for understanding climate change.
Scientists are always working on each other. They're criticizing and commenting on each other and trying to improve our work. So there's a process of self-correction in science. We make mistakes, but the very nature of science is that we come to understand that that was a mistake and this is the right answer. That makes the scientific process the best hope we've got for understanding climate change and adapting to climate change.
At the national level, many federal agencies are working to slow greenhouse gas emissions and prepare for predicted changes. Some have their own climate projects, while the U.S. Global Change Research Program unites 13 different government agencies to coordinate climate change policy. The Government Accountability Office placed climate change on its high-risk list in 2013. President Obama has also made climate change a priority.
But for the sake of our children and our future, we must do more to combat climate change.
This makes sense given the public's feelings on the environment. Dr. Bob Oldendick, director of the USC Institute for Public Service and Policy Research, studies and researches public opinion.
From the time we started polling on this, the key question asked by Gallup and a number of different agencies ask a similar question is the trade-off versus is it more important to protect the environment or more important to protect jobs and grow the economy. And what we found really for the period of about 35 years was that the environment always has the majority support, that people are concerned about the environment. But then with the economic downturn and with 2008, we started to see the trend line switch. And it was really in the beginning of 2009, for the first time, a majority said that creating jobs and promoting the economy was more important than the environment. We saw a little switch in that. It flipped back to majority protecting the environment after the oil spill. There was about a 10-point shift in a month. And then in 2010, and since that time, it's close to 50-50. There are big party differences in the sense that the Republicans are less likely to believe that climate change is an issue or is a problem. But there also is a strong difference across age groups. And it's younger people, it's particularly the under 30 age group, that is much more likely to think that climate change is an issue, that change has been occurring, and that's a problem.
2012 was the hottest year on record in the U.S. National temperatures are predicted to change at least 1.5 degrees Celsius or 2.7 degrees Fahrenheit on average by 2100. This is a small change compared to what many other regions will face, but it will have a huge impact on crop yields, making some areas better for growing certain crops and some regions unsuitable for harvesting crops that have grown there for centuries. Weather patterns across the U.S. will also change to become more extreme.
If you're living in Florida, yeah, it's bad for you. If you're living in North Dakota, things might actually get really nice.
Sea level rise will have a large impact on many coastal areas. It's predicted to rise between 8 inches and 6.6 feet by 2100 in the U.S. An estimated 8 million people live in vulnerable areas across the nation, according to NOAA. The most vulnerable areas are the Gulf Coast, predicted to see a 3-foot rise this century, and the Chesapeake Bay, predicted to see a 2-foot rise this century. South Carolina, a coastal, southern, already warm state, will be directly impacted. Our state is predicted to see 20 to 30 more days per year over 95 degrees Fahrenheit by 2070.
It's going to be hot enough to be unpleasant here, and we could be, but we aren't yet, thinking about how to deal with that.
And it won't just affect our air conditioning bills.
Temperature changes will affect what grows in the state. They'll affect the seafood industry, which is very important to the state, and they'll affect the coast. The most important of those controversies involves the question of sea level rise, which is connected to all this, of course. And the fact that we've built right up to the edge everywhere we can, and the question then being, how do we get back? How do we walk back from the coast? Property owners don't necessarily want to do that, but then when there's a storm, they want to be held harmless for the consequences. Do we give them insurance? Well, South Carolina is a small state with a little over 4 million people, and so an insurance pool against a hurricane is inevitably not big enough, and we're going to have a problem when we have a storm, that there are going to be all these people who need help, and we don't have enough money to help them.
Most of South Carolina's coast is between moderately and very vulnerable to sea level rise. Charleston is predicted to experience a 1-foot rise by 2100. This, unfortunately, puts portions of historic downtown Charleston underwater.
We have to look at ourselves and say, wait a second, we've got homes and businesses and other things that we care about in places that they're vulnerable to the effects of climate change.
It's more challenging to precisely predict these things on small scales.
I can sit here and say with great confidence that sometime this century, the temperature of the globe is likely to warm 1, 2, maybe even 4 degrees C, maybe even warmer than that. But can I tell you what happens in the southeast or in South Carolina? That becomes much more difficult.
South Carolinians do care, and state governments are starting to prepare for predicted effects.
And people in South Carolina are really not all that much different than the rest of the country in terms of that trade-off of the economy versus the environment, so that we still see some kind of strong support for kind of environmental issues.
Being such a large university of 31,000 students comes with an environmental cost. According to a survey that I conducted, 16% of students live off campus and drive less than 2 miles to campus for class instead of walking, biking, or taking public transportation. We can be very conservative and say that this is an overestimate because many students only have to go to campus 3 or 4 days a week. We can have that to 8%. And we can also conservatively say that they are driving 1 mile each way in cars that get 40 miles per gallon. With these very conservative estimates, these students are emitting 1,085 kilograms of carbon dioxide equivalent per day. That's like me driving my car, Suzanne the van, from campus at USC to my house in Baltimore and back a little over 2 times. To take that carbon dioxide out of the atmosphere, we would have to plant a tree and let it grow for 40 years. And again, that's just for students who live close enough to walk to drive to campus 1 day.
You look at other campuses here in the state, Clemson has buses that run out into the residential neighborhoods. And so students can get a bus that goes to Clemson. Don't have to have a car. That's sort of cool. We could do more of that, of course.
Then there's the impact of running campus. According to facilities, we use 202,645,780 kilowatt hours of electricity in a year. This converts to about 106,312,028.1 kilograms of CO2 equivalent in a year. Divide by 365, and that's 291,226 kilograms of CO2 equivalent emitted per day on average. That's like me driving Suzanne the van from campus to my house in Baltimore, Maryland, and back 749 times. That's a little more than a Boeing 747 flying 400 people from JFK in New York City to London Heathrow Airport. That's so much carbon dioxide that we would have to plant 321 trees and let all of them grow for about 40 years to take that carbon dioxide out of the atmosphere. And that's just the electricity that USC uses in 1 day. That doesn't even include gas and oil, which are much harder to get accurate data on. The other problem is that the USC budget is tight, which may prevent us from being as green as we would like.
It's not clear yet if we're going to raise enough money for the new law school to make it a really energy efficient building or not, and so on and so forth. And we're going to have to renovate some old buildings, and the question is how much money can we put into those to deal with the challenges that they present.
You know, we can always do better, but I'm confident that we will.
There are a lot of great things going on at the university to mitigate climate change and promote sustainability.
We're doing a pretty good job of building new energy efficient buildings.
The Green Quad was awarded a LEED Silver rating in 2005. The Honors Residence was awarded a LEED Gold rating in 2010. Patterson, the women's dorm, was awarded a LEED Gold rating in 2011. The new business building, set to be ready next January, is on track to be awarded the highest possible LEED rating, Platinum, and to be the largest net zero carbon building in the world. Recycling and waste management on campus is growing and improving.
We're working really hard to make it easy for people to recycle mixed paper, aluminum, plastic, cardboard. That value really translates to something real for the university. We collect that material and then we get a rebate when we recycle it, and that helps fund the program. You know, the goal is if it's going to be as easy to recycle something as it is to throw it away, then every time you have a trash can, you need to have a recycling bin. And one of the ways that we've accomplished that recently is with the installation of the Big Belly solar compactors around the Russell House, which provide that parallel access. you've got a trash can, you've got a recycling bin. Coming up, we're going to be doing a single stream recycling pilot project in the library that will allow us to do that parallel access, so every time there's a trash can, there'll be a recycling bin, and plastic, aluminum, mixed paper can go in the same bin. And the way we're able to do that is that recycling centers have improved their technology so much that they can sort it at the recycling center, and we don't have to sort it before we give it to them. We have some lofty goals on campus. Our current recycling rate is about 20%, between 15 and 20%, which is great. That means that of everything that we throw away, either in a trash can or a recycling bin, 20% of it isn't going to the landfill. We would like to get that to 40%. That's going to take some work. Eventually, we'd like to get to zero waste, which means that 90% or more of everything that is considered waste doesn't end up in the landfill.
We also do some composting on campus.
You can see those 2 stations that are for compost. So we do make our own fertilizer with kitchen scraps from vegetables, eggshells, coffee grinds. 3 months time you get a big, 3 cubic foot area of clippings and vegetable scraps that composts down to a very kind of a granular dark brown dirt looking substance, which really is odorless and is full of nitrogen and good things for the garden. The students have been given one of those little green golf carts, and a bunch of them go around to all the places where food is prepared on campus every day, and they collect all the scraps, the vegetable scraps, for composting on campus at the Green Quad. And I was told, I haven't verified it, but I was told it's 200 pounds a day.
The biggest green effort on campus is being made by Sustainable Carolina, a campus-wide organization. Dr. David Whiteman is the faculty coordinator for curriculum and leadership at Sustainable Carolina.
So it started with 3, and now, if we count all the interns and all the people associated in various ways, we're up to like 70 or 80 people, on the what we consider the staff of Sustainable Carolina. And we've really developed a campus-wide organization that's designed to help facilitate people working together to create a sustainable campus and community. What we've been trying to do is just in a really broad way to change people's consciousness and awareness of all the issues related to sustainability. So we tried to look at things across the board, everything, some of the more specific things we've done is, looked at recycling issues, trying to look at issues around the built environment and green buildings, looking at issues around transportation and energy and all those areas. More generally, we've also tried to look at some of the more philosophical areas. We have a Greening the Mind team that it tries to raise people's awareness of some of the more philosophical dimensions of sustainability. And then we've developed a leadership program that also indirectly affects all these things, because we try to get students involved in being leaders and training them to be leaders for the campus, but also for the future as well. So one of the most successful projects from the beginning has been issues around food, and that's really taken off. We have our own garden. We have developed other gardens on campus. We've also have a really active set of workshops and things on gardens and planting seeds, and the whole range of activities. So that's been a major part of the activity.
Another big proponent of gardens on campus is Mrs. Patricia Moore Pastides, First Lady of the university.
This is my primary claim to fame as First Lady, is an organic vegetable garden, which we started 5 years ago. I wanted to cultivate organic vegetables to use at our events, primarily, which we have 200 some events every year at the President's House. And I wanted to be able to move us from the traditional, carving meat stations to more healthful eating, which in my opinion is more plant-based. This is the Carolina Community Garden. It was started by Outdoor Recreation a couple of years ago. We provide water and compost material for these growers, and these can be any students, faculty, or staff, but they have to be at least 4 people to 1 raised bed, and they sign up to cultivate it for 1 semester at a time. I think this is really fun. It brings a lot of people over here to the garden. it's, you know, getting the word out that growing your own vegetables really doesn't take that much time. You know, once you get those little seedlings in the ground, you just have to make sure they're watered, and basically there aren't too many weeds in the raised bed, and it kind of just takes care of itself. After the outdoor rec got this project going, the men who work in facilities asked our gardener to come down and help them plan a garden for their workplace.
Every Tuesday in the fall and spring, Healthy Carolina sponsors a farmers market in the center of campus to help students buy more local food. Campus has also changed in other, more subtle ways in the past several years.
I've definitely seen the campus become more green, primarily because of our students' involvement in everything sustainable. So we have Sustainable Carolina and SAGE. I mean, there's so many organizations on campus, including, you know, living and learning communities that are really interested in, you know, being more sustainable.
I do notice that there's a lot more people carrying their own water bottles, and the new trash cans that we just got installed in the last couple weeks.
When I think back at how things have changed over the last 10 to 11 years, it's been tremendous. Recycling, we didn't even have recycling containers. Now everybody recycles, and you recycle everything. People walk through the hallways and they talk about lighting, they talk about energy efficiency. I mean, that's fabulous.
If we look at what's happening and the number of people involved in the, you know, the activities and courses that are being taught, you know, it's quite amazing, and it's really, I think it's you know, it's partly due to our hard work, but also just part of a national, you know, there's a whole national movement on campuses to create this kind of help create this kind of culture. So it's been exciting to, you know, see that happen in the past.
What I think of as good news is that the people who do parking have been pushing everybody into parking garages on the periphery of campus, trying to get people to walk. And I know for students that's sort of, oh, come on, but that's a good thing. We can run efficient buses around campus, and people can get around campus without moving cars and without having parking lots.
All of this effort really adds up. We can be very proud that USC won the highest rating on Princeton Review's 2013 Green Honor Roll for colleges and universities.
We've got a great campus population. We've got a student body that believes in recycling and sustainability, and an administration that has gotten behind it.
USC professors study climate change in the policy and scientific realms. Dr. Mark Tompkins is an associate professor of political science and director of the USC MPA program. He studies health and environmental politics.
From my vantage point as somebody who teaches public policy and who fits around in public policy, the real challenge is helping the public understand what climate change means for us, and helping people value solutions to the problems that we can see on the horizon. One reason it's a challenge is because so many people say, oh, it's a bunch of scientists, it's a bunch of geeky people in the ivory tower who don't care about real people. The irony being that we do care about real people, but we're telling people about things that are going to be hard to do.
Dr. Seth John is an assistant professor in the Marine Science program and Earth and Ocean Sciences. His research centers on the chemistry of the ocean.
The specific research that I'm working on right now is looking at iron deposition into the oceans. Iron is an important micronutrient for phytoplankton. So if you have a large dust deposition event to parts of the ocean that are iron limited, then that can cause a huge bloom of phytoplankton. And those phytoplankton, of course, are taking carbon dioxide out of seawater and therefore out of the atmosphere and sequestering it into the deep ocean.
Dr. Jean Ellis is an assistant professor in the Marine Science program and geography, who studies many aspects of the coastal zone.
I investigate coastal processes at different scales. I look at beaches, how the sand moves, how the waves move, and I also look at land use and land cover and how that affects the nearshore waters, how that affects nearshore vegetation, how that affects conservation and management decisions. Talk about my water work, we're looking directly at trying to alter the coastal system by putting shoreline protection structures, whether it be hard engineering or living shoreline structures, and the shorelines are eroding because of climate change or because of human impacts to the environment, such as other structures that are being built.
Dr. Howie Scher is also an assistant professor in the Marine Science Program and Earth and Ocean Sciences. He researches past climate events.
I am a paleoceanographer, which means that I reconstruct the Earth's past history using marine sediment cores. I sail on a big ship with a gigantic drill rig. We want to drill a hole and bring up the sediment core. All right? And the sediment cores are a chronological record of Earth history. If you think about the average sedimentation rate in the oceans, it's about 10 meters per every million years. So we drill sediment cores that are about 300 meters long. So we can get back millions and millions of years ago. Now the reason I'm doing this research is because if you want to look at how the Earth behaved with carbon dioxide levels at the level where they are projected for the 21st century, you've got to go back 34 million years ago. I'll say that again. You've got to go back 34 million years ago. That means that carbon dioxide levels in our atmosphere have not been as high as they are projected to be for 34 million years. There are a lot of chemical and physical signals or measurements that we can make in the sediment that relate directly to climate.
Dr. Scher dissects these sediments to look at tiny plankton called foraminifera.
Using all of the little forams in this glass vial, we can reconstruct past temperature, past carbon dioxide levels, and we can start to think about things like climate sensitivity. Climate sensitivity means how much will temperature change with a given increase or decrease in carbon dioxide. And we can do this for millions of years in the past to see how much we should be concerned for the future.
Dr. Claudia Benitez Nelson is the director of the Marine Science Program and professor of Earth and Ocean Sciences. She analyzes ocean biochemistry.
So my research is in biogeochemistry. So I look at, actually my main focus is looking at how things make their way from the surface ocean down to the deep ocean. I look at how particles form, how they make bigger particles, and then how those particles actually sink through the water column and what happens to the composition of those particles as they sink. When you think about where does carbon dioxide go that's produced and emitted to the atmosphere, you know, a substantial portion of that goes into the ocean. And it's the stuff that makes it from the surface ocean to the deep ocean that really locks it away for long time scales.
Dr. Greg Carboni, chair of the Geography Department, studies climate variability and impacts.
I'm a climatologist, and so my starting point is to say, how can we use the instrumental climate record? This is the shorter term, like 100, 150 year record, globally, regionally. How do we use the instrumental record to determine interannual variability, interdecadal variability, and potentially long-term climate change? So it starts with the historic record. For most of the stuff that I do, I'm interested in the instrumental historical record of those kinds of variability and change through time. Temperature, precipitation, anything we measure, and anything that we've systematically measured. I've spent some time thinking about hydrologic impacts, drought impacts, agricultural impacts. So it's really kind of focused on ag and water resources, the impacts that we've seen historically, and trying to project something in the future about that.
And Dr. Kirsten Dow, a geography professor, is directly involved in global climate change policy. She is helping to write the next IPCC report, due out in 2014. Many of these professors also teach climate change in their classes.
A large part of my job is teaching. I teach a lot of these service classes where their only relationship to a climate class or a marine science class will be mine. So that's kind of scary to think about the impression that I can have on these students.
I'm no longer a graduate student. I'm now a professor in charge of telling, hundreds of undergraduates what's happening and whether climate change is real or not. And so I also sort of feel a social pressure, a psychological pressure to be less ambiguous about it. And I sort of feel like I ought to get up there and just say, no, listen, like the evidence is in, it's like a closed question, climate change is real, climate change is happening, it's anthropogenically caused, and it's just, there's no more debate about it.
I definitely do say that climate change is happening in my classes, and try to relate to them that the climate and the things that we see now are a combination of natural fluctuations exacerbated by the human impact. So I don't exclude the natural fluctuations from my dialogue when I'm teaching, but I try to really emphasize that the state we're seeing now is incredibly influenced by humans, and it's something that we could change, or something that we could at least impact and by changed behaviors.
I actually change the conversation in my courses not to is climate change happening or not, but what are the consequences? What are we willing to live with? What do you think we shouldn't live with? What are the economic realities of these various things that are ongoing? And that then is a very different conversation. If you want to argue to me about the economics of climate change, that to me is a very different conversation than whether climate change is occurring or not, because that's just silly.
Most students seem to agree. In a survey I conducted of 815 students, 83% said that they were somewhat, very, or extremely sure that global warming is happening. 66% thought that global warming was caused mostly by human activities. These data are higher than national numbers, which show only 70% believe it's happening, and only 46% believe it's caused mostly by humans. Other data I collected is also encouraging. 79% think that USC contributes to climate change, and 69% think USC should consider global warming in its administrative decisions. 78% think that their personal actions contribute to climate change, and a very encouraging 94% would be willing to change their life to some degree to help stop climate change. Some of these students are especially worried about climate change. 17% claim it's extremely important to them, and 8% would be willing to change their life a lot to help stop climate change. Sarah Wilson is one of these students.
I think that climate change is something that we definitely need to focus a lot of energy and attention on. It's something that humans are definitely contributing to. I think it's important to start focusing on climate change while we're here at the university, because certain things that we start to learn now will become part of our behavior change that we'll be able to carry on into our lives after college.
Unfortunately, there is still a very small group who are dismissive. 8% are somewhat, very, or extremely sure that global warming is not happening, and 6% wouldn't want to change their life at all to help stop climate change. Alex Morgan is more on this side of the spectrum.
You can't really judge the past 100 years based on what's something that's been happening for millions of years. Basing policies and stuff like that is killing small business. All these regulations, we've had ice ages, we've had periods that are a lot hotter than this. It doesn't necessarily correlate with all the pollution.
There's this small active group that's really concerned about the issue, but you're going to get in on a large, diverse setting like this. You're going to get most people that's not really something that they're interested in or care that much about.
They're not really sure about it. They don't really know what to think. They've heard a lot of things. They're like, I think I'm concerned, but I don't really know.
And there really hasn't been a flashpoint until something comes together that says, okay, we really need to do something about this. Then people are going to be distracted by other things. I mean, there's a dance marathon this weekend, so I got to be concerned about that, not saving the environment this week.
Even more discouraging are the 7% of students who never learned about climate change until college, and the 1% who still haven't learned about it.
The students are really fascinated, that they don't act like they've receive this information anywhere else.
But efforts on campus are working really hard to improve these numbers, and it seems to be showing. 56% of students have taken a class on climate change. Over 90% have heard about recycling efforts and the farmers market, and 58% have heard about our LEED certified buildings. We can only hope that these numbers will increase and that more students will move towards the concerned end of the climate belief spectrum. There are some big messages that we can take home from all of this. First of all, we know that humans are contributing to climate change, but it's hard to be sure how much things will change.
In 20 years of serious modeling, we still have about the same range in understanding that sensitivity. So we will live, the 21st century with that level of uncertainty. There's no question about that. And our decisions about the future have to consider that. There's no way around it.
Second is that climate change could pose a real threat to our planet.
Of course, on a several million year time scale, we're going to be just fine, because eventually all the carbon dioxide in the atmosphere will react with silicate rocks. And through the reaction of that carbon dioxide dissolving basalt and granite, it will turn into bicarbonate, so it will take the carbon dioxide out of the atmosphere and react it away. The obvious problem with that being that it takes about 1 million years for that process to take place, which is a long time to wait in the meantime.
There's an old saying that you never want to poke a sleeping dragon. Well, you really don't want to poke a sleeping dragon with a double-edged sword, and that's sort of what we're doing. We are firing anti-aircraft missiles at hordes of sleeping dragons by burning fossil fuels at the rate that we are burning them.
Can we afford it?
And finally, we as individuals and as a university contribute to climate change. But we are capable of great things that can help slow the impacts.
Climate change carries real risks, which have to be weighed against the real costs of moving away from fossil fuels. So there may not be a simple answer to climate change, but somewhere in there's something that we can do.
The big issue is the political layer of climate change. That there are a bunch of people who just don't want to deal with climate change. That's a big deal for a state like South Carolina. It's a big deal for the university.
We haven't had a BP oil spill for a couple of years. We haven't had this, the kind of things, the hurricanes, the kind of natural disasters that some people say, well, these are getting worse because of the global warming and because of changes in the environment.
Trying to talk people into spending money now for something that happens later. That's part of the challenge.
As a university, we can continue to do all of the great things that we are already working on, and we can improve on things like using less electricity and walking or biking to class more often. We have to be willing to spend a little more money or a little more time on things that will help. As individuals, we have to spread the word, vote for politicians who care, and change our behavior, even just a little bit, to lessen the impact and keep the natural world around for future generations. Only by making this issue a priority can we make this crisis a little less close to home.